To make these ideas clearer, let's take some of the examples of machine learning that we looked at in the previous module and describe their features and their labels. Take AucNet, for example. This is the car auction site in Japan that was able to predict the value of a car from photographs of the car. AucNet needed to have historical data that contained photographs of cars and the price that they sold at auction for. Otherwise, they would not have been able to train a model that predicts the price of a car given photographs of the car. It goes beyond just having pictures of the car. You need specific pictures. The model was trained on pictures of the car from different viewpoints, from the front, from the side, a close-up of the bumper, the interior, etc. Do you want to use a condition of the tires, for example, as one of the features of your model? Then you need to have photographs of tires in your historical dataset. Do you want to be able to value buses, not just cars? You need photographs of buses in your historical dataset. But you also need the price that the bus sold for. The price is the label. And because price is a number, the framing of this problem is a regression problem. Or take the YouTube recommendation example from the previous module. YouTube recommends the next video for you to watch. For that to happen, the historical data that the machine learning model is trained on needs to include what videos users watched, not individual users. After all, you are probably watching this video for the first time, and the video that YouTube recommends to you, you probably haven't watched before either. What YouTube needs is the aggregate history of all of its 1 billion plus users and who knows how many videos. Aggregate information such as which country you're in, what genre of videos you tend to like, how many of the people who watched this current video went to watch the next video. Those are the input features that YouTube is able to use to suggest the next video. The next video is a label, and because we identify videos by a video ID, the video ID is a label, this is a classification problem. Even though labels are necessary, choosing the right label isn't always obvious. And not surprisingly, choosing the wrong one can negatively affect your model. Let's take a banking example. A bank might be interested in predicting how much a current customer will deposit over the next 10 years. That means that we need data of customer deposit that goes back at least 10 years. But this poses all sorts of problems. Did people earn the same amounts over the past 10 years? Did our bank open new branches? If so, customers in the new branch might be different from those of the old branch. Was there a recession before? If so, then that period might not be a good predictor of the immediate future. All these make the problem of creating a machine learning dataset for this problem quite hard. The next 10 years will be very different from the previous 10 years. When I say predict the next 10 years of deposits, this is what I mean. The feature for the model are all the amounts deposited in the past some number of years. Here I've used 10 years, along with any other factors of those 10 years, like the economy and so on. And the label is a set of 10 values for the next 10 years of deposits. This is hard. It might be easier instead to create a machine learning model to predict how much a customer will deposit over the next 1 year given 5 years of history. And that's what I've depicted here. Notice that the feature in this case is 5 years of data, and the corresponding label is the 6th year of data that's shown by the yellow segment. Then, the next 5 years of data is the feature, and the 7th year is the label. if you formulate the problem in this way, you will have a lot more labeled data, and you can also use the state of the economy, median income, where the branch is, etc. as inputs to the model. So understanding that machine learning depends on examples and that you need labeled examples will help you formulate the problem in a way that allows it to be solved. After all, you don't want to promise your boss that you will create a 10-year model and then find out the hard way that it doesn't work as well as you imagined. I will return to this subject of how to go from a business need to a well-formed machine learning problem in the section on problem framing, which is a part of the model training phase.